Hi, I'm Lin and here's my circuit. So basically, this is the signal analyzer. This part is a low pass filter. This part is a high pass filter. This part is a skimmy trigger. So basically, you can get various signals from this analyzer. If you want a signal without a high frequency, you can connect it to this part. It's a low pass filter. If you want a signal without low frequency, you can connect it here. And if you want to convert any kind of wave to a square wave so that it can perform some digital implementation, you can connect it with a skimmy trigger so it can convert a sine wave or a triangular wave to a square wave. So for the skimmy trigger, I use the value provided in the lab 8. So I use the V reference as a 1.8 volt and I make a VF as a 5.5 k ohm and V1 be the 1 kilo, so the ratio is around 5.5. So this is how I set the value for skimmy trigger. So let's move on to the circuit. So these are my circuit design. So first, this is VCC, this is V ground. This part is low pass filter. So as you can see, the negative input is connected with this 3.9 kilo resistor, and the resistor is connected to the signal input, and the positive input here is connected to the ground, and also the output is connected to with a resistor and a capacitor in parallel, then connected back to the negative input. So this form low pass filter, and this part is a high pass filter. So as you can see, first the signal is this right where it first connected to a 1 mil capacitor. So the capacitor is then connected to a 8.2 kilo resistor and connected to the negative input, and the positive input is connected to the ground. Also, the output input is connected to a 22 kilo resistor, which then connected back to the negative input. So this together form a high pass filter. And finally, the skimmy trigger. So this part is the skimmy trigger. As you can see, the signal input is connected to here to the negative input of the skimmy trigger, and the positive and the output is connected to this RF, which is a 5.5 kilo resistor, and then connected back to the negative input. This is connected back to the positive input, the gray line here, and also this VF is connected to the 1 kilo resistor and then connected to the V reference. So this generates a constant 1.8 volt voltage. So it serves as a V reference. So overall, this is a skimmy trigger. And now let's perform the simulation. So let's first initialize the power supply, and let's first test the low pass filter. So if I connect the input to the low pass filter, you can see this is you can see the curve here, it matches with the low pass filter curve. And now if I connected the input to the high pass filter, I connected the output to the high pass filter, you can see the curve here is a high pass filter. Finally, let's say the scheme trigger. So the signal generates a 4-volt peak-to-peak signal with a 2 offset, and channel 2 is like the V reference is 1.8 volt. Let's run the oscilloscope. So you can say turn a sine wave to a square wave. This is what scheme trigger does. Yeah, and that matches with our expectation. So thank you very much.